wherever you like. Okay, so I'd like to welcome everybody to this month's edition of Big Data Value. My name is Siddharth Agrawal. I'm the organizer. My co-organizer is Chaitanya. We've been running this meetup for over 10 years now. And, it started off in the days of Hadoop. Like I see looks like it's a mammoth rather than an elephant t-shirt. But, the big data landscape has evolved significantly since then. And I always feel I'm learning something new. So even today, it's like, okay, this is an opportunity to learn more about, the latest development, which is AI. But, the group is about how to solve problems at scale using, technology. And those typically involve a lot of data. And, there's an explosion of data that's continuing to go on. This month's topic concerns utilizing AI models and determining how reliable, efficient, effective they are. So one of the things you may have heard about AI models is even though they seem like they can answer all your questions, it really is a question like how reliable are they? Like, can you trust what they're saying? And so in tonight's talk, we'll get an opportunity to learn from a startup who is a CEO of the startup who is focusing on solving this problem, so to learn more about what are the issues and, how you can deal with them. And then we'll learn more about, what the solution is being presented to tackle this area. But with that, I'd like to introduce Vishnu.
Hey, thanks a lot for that. Yeah, my name is Vishnu. I'm the CEO founder of WiseCube, and I have Alex here with me. He's the principal data scientist. Let's get straight into it, shall we? I'm just going to say it. Gen AI, for those of you who don't know, is pretty unreliable. All right, if you haven't heard of any of these news articles in the last couple of years, I'll just give you a quick summary that there have been a lot of sort of missteps, let's call it, with companies sort of rushing in to adopt generative AI. It is an amazing technology, don't get me wrong, right? But there have been a growing number of instances where a company sort of rolls out Gen AI without really doing due diligence or making sure there's guardrails and checks and balances, and then sort of blowing up in its face, right? The one thing I wanted to call out was like specifically the Air Canada instance. If you haven't really heard about it, they rolled out a chatbot. Chatbot decided, hey, we're just gonna say it's gonna say whatever it is to make the customer on the other side happy and start promising refunds to everybody. But the policy clearly didn't really dictate that. And so Air Canada was like sued, and it was just a big debacle. Bing misstating financial data, that's another one. Google apologizing for its models. So you're starting to see more of this as people are adopting this technology and just rushing. Really, the last 2 years have been all about how do we get our hands on this technology? How do we be first to market to try to sort of sprinkle some Gen AI pixie dust on our products, right? That's basically what every company on the planet's been trying to do, right? But the truth is, it is pretty unreliable. And the dirty secret is nobody is really measuring how unreliable their products are, right? And these errors are costly, right? Spreading false information or impaired judgment. There's a lot of bias. And there are things that people are doing. You've probably heard of graph RAG, things like that would like supposedly try to reduce the amount of errors and biases in these products. But the numbers are still astounding. Like some of these numbers, some of these models, 27% hallucination rates. That's insane. Like if you use like QuickBooks or like your TurboTax and it got your tax numbers wrong, like 27%, like you would never use that product, right? But then we just seem to accept that, hey, it's okay. Hey, this is a magical technology, so we can just let it be wrong like 1/3 of the time. That's right. And then think about like if you're in healthcare, right? Where a customer of ours, they were like had the brilliant idea, like we're going to take all of these patient summaries, we're going to feed it to an LLM, We're going to show those summaries to a doctor so the doctor can then decide what to do, like actual clinical decision management. We were like, are you guys measuring this stuff? How are you going to measure this stuff in production? And they had no good answer. They were just like, well, we had a benchmark. We're going to run the benchmark on a test data set, and then we're going to ship the product. You know what that sounds like? It's like, we have unit tests. Our unit tests passed, so we're going to ship the code. That's what people are doing now. Most people, this is what they do. You ask about reliability, they're going to tell you, oh, we have a golden data set. And our golden data set and our benchmark numbers, they're really great. And so we're going to ship the code. But guess what the problem is? They're taking this black box that's super complex, and they're throwing all kinds of data that it's never seen before, and they have no idea how it's going to react. And they're not even monitoring it. Right? Which should be scary. Hopefully you guys are all scared by now. But this is happening in every enterprise. Most enterprises, this is what they do, right? I'm not blaming anyone, but that's just the way things are right now, right? And the costs, at some point, somebody's got to pay these costs, right? Most enterprises seem to get away with it because they put big disclaimers saying, hey, you know, we don't take any responsibility for the results here. You're on your own, right? And you know, the Facebooks of the world can probably get away with that, but if you're doing anything that's like meaningful and mission critical, you know, you can't really do that. The option, you know, anyway, we'll talk about it. And by the way, the regulations are here, right? If you heard about GDPRs and all of that for data privacy and all of those things, those regulations are finally catching up to AI, right? Europe obviously is leading the way. There's some states in the US that have already passed laws. Colorado, California is gonna, I think, you know, follow suit. So it's going to, I don't think the United States per se will pass a federal law because, you know, we don't really do laws anymore, at least not at the national level. So, but it's here, right? And so the regulations are going to come, which means if Europe has already passed the law, the AI Act is not even an act, it's already in force. And they have the deadlines that said like, hey, by 2025, you got to do this, this, and this. You got to first classify your risk categories. If you're using LLMs, you're considered high risk, right? And that means you have to be much more transparent and you have to have more oversight, right? So it's already here. So here's the dirty secret, right? Gen AI, and this is not me saying this, Gartner published this, they updated their hype cycle. For those of you who don't know what a hype cycle is, this is sort of the typical adoption curve for most technologies sort of go through, right? Gartner, I think invented this, but they have this thing where they sort of map out different technologies and they say, where in the hype cycle is your technology? And typically what happens is it starts out with the innovation trigger, where like everybody's super excited about it. It's like, oh my God, this is the next, you know, best thing since sliced bread. And then, and sort of goes up and then eventually it hits a peak. And then it sort of starts dropping, right? And then you have the trough of disillusionment where people are like, oh my God, this is the worst. And then eventually they realize what it's truly capable of. And then it plateaus, right? And every technology sort of goes through this sort of cycle. And the thing I wanted to call out was, well, check out what Gen AI is, right? It's past the peak, right? Which means, and then there's a color, like, and there's a, you know, the color and the shape of the thing they've used also denotes what is the, according to Gartner, how soon do they think it's going to plateau? That particular technology. That's sort of what it also indicates. So if you see a blue, light blue circle, they think it's going to like 2 to 5 years, right? So next 2 to 5 years, they think Gen AI is sort of going to plateau, right? Anyway, just an introduction. So yeah, we're from WiseQ. We sort of focus on this kind of stuff, especially mission critical things. We've been in the healthcare pharma space for the last 5+ years, building sort of AI products and semantic AI products. Hey, Alex and myself here, we work with a lot of different healthcare and like pharma companies as well. But the thing that I wanted to talk about is today, okay, if this is the problem, and what are we going to do about it in the next 2 to 5 years? And the big takeaway, I think, is going to be where developers need to start focusing more on these incoming regulatory changes. They have to start building more observability solutions, more transparency solutions, and more importantly, cost is going to become a bigger factor, right? Where everybody was just throwing money at OpenAI and saying, hey, we just want this stuff, we don't care, just build it. Now you're starting these CTOs and CEOs saying, and I was talking to Amazon the other day, they were talking about this, where like they're seeing all of their customers go through this as well. The first 2 years was all about like, hey, let's just throw money at this problem, let's build something cool. Now they're like, hey, this is costing us way too much money. How do we get more efficient? How do we optimize the cost around this? How do we build more reliable solutions that can actually scale to our enterprise level? Right? So cost is also becoming a big factor. So keep that in mind as well. And we'll talk about how we can address all of those things. Before that, let me take you on a brief sort of detour about how observability works in like sort of today's enterprise world, right? So for those of you who are sort of new to this whole, software industry, maybe like typically what happens is you have some sort of an enterprise application you build, right? And in order to understand what it's doing in production, right? So you assume you've done all your testing, your unit tests, what have you. You've shipped it into production. Now it's running, it's taking inputs, it's producing some sort of an output. You want to know how it's doing in production. Is it behaving well? Is it like airing out? And so what the logging is obviously the number one. I haven't called out logging here, but logging is also part of this observability stack. And then you can also push metrics into things like there's tools like Prometheus, which track all of the different metrics that like things like, hey, what is your CPU? What is your memory utilization? Anything that's like a time series data that you're tracking that can tell you more about the health of your system, you sort of push into these sort of Prometheus-like systems. Now traces are slightly different. They're not logs. They could be used like logs, but they're not. I'll talk more about traces later, but think of traces as it was a way to sort of do distributed coordination or at least monitoring amongst different microservices. So you have like multiple services doing one thing. Let's say you go buy something from PayPal or whatever. There might be like 15 services behind the scenes that are doing all of these things. But for you, you just made one transaction, right? So if something fails, you don't know which one of these 15 services actually dropped the ball. So that's how traces, where distributed tracing really comes into the picture, where you can figure out for that one transaction what happened across all of these 15 services and stitch them together, right? So that's what tracing does. There's open source solution called Jaeger that's pretty good at sort of keeping track of traces. And then you have a visualization solution. The one that's really popular is called Grafana. It sort of looks at all of these metrics and traces from one sort of single pane of view. And then you can look at all your logs, metrics, and traces from one. Anyway, so this is how you sort of continuously monitor your application that's already deployed in the production, right? And this could be a big data application, it could be an AI application, it could be just a like old school deterministic, a software application that boringly does what it's told and doesn't make up stuff, right? So, but here's where it gets complicated, right? Like the traditional stack, what I call software observability, and there's this concept of levels that I want to introduce, right? Most people sort of stop at this level 1, which is like, hey, it's okay. We just monitor things like we, check the health of our application. Is it up or down? Is it available? And collect just basic alerts, metrics, and logs, like the one I just showed you, and we're fine. And most people stop there. But more and more, we know in sort of a data-rich world, it's not enough to just know if your services are just up or down, or if they're healthy. Like you got to track things of what's going on with your data. Like, is your data volume going up or down? Are there schema errors in your stuff, right? Is my processing taking too long? Am I running behind in terms of like my queue capacity? Or like somebody was talking about Kafka. It's like, hey, my Kafka consumers, are they backing up, right? So that kind of stuff, you also want to start tracking to see if your pipelines are also healthy and the incoming data is also healthy and the outgoing data, right? So that's another level of observability that typically you sort of need because you're operating with like huge amounts of like fast moving data, right? Either streaming data, batch data, whatever it is, you're doing something, everybody's doing something with data. Customer data that's coming in, you're importing customers' data, you're doing some processing, you're enriching it in some way, you're shipping it back. So, right? And so this level of observability, like most people don't explicitly think about this, but this is something that, they should be thinking about, like, hey, how can I have this level of observability? Now if you add another whole level of like, the AI models into the mix, you got a whole other randomness that you just added, right? Now you don't know if it's like, those of your fans of hitchhikers, there's this concept of like the infinite improbability drive. That's how I think about LLMs. It's like, you don't know what it's gonna do. You might go where you want to go, or you might end up as what is it, Alex? I think it was like a flower pot. Flower pot. Yeah, you might end up as a flower pot. One of the two things can happen, but so you want to measure and monitor that thing. It's like having a really smart person who's really good at lying to you, right? How do you know if that person's lying to you? Because they're so smart, they can just make up stuff that sounds so credible that you're never going to be able to question them. That's the kind of person now we've introduced into our software stacks. So we better keep track of this stuff, right? Otherwise, we don't know, like nobody knows if it's true or not anymore. And then we're going to tell our customers something based on what this person said. Sounds insane, right? But that's what everyone's doing. So that's why we need a whole other level of observability to really, it's like watching the watchers, like who's tracking the AI, the intelligence. So you need more intelligence, unfortunately, to figure out if your intelligence is lying to you, right? And is it being fair to other people? Is it introducing new kinds of biases? Is it actually vulnerable to, security attacks? If you've heard about all this, jailbreaks that can happen on LLMs, right? You can give a certain kind of prompt, sort of trick the LLM to break its safety, guardrails and whatnot, and have it do all kinds of things. It's a constant problem. Yes, these models are getting smarter, but guess what? People are going to keep trying to break those things as well, just like security, right? The classic example I would always go back to people, the metaphor I always use, like think security paradigms, right? Just because you write secure code and you check for OWASP top 10 things, and you stop your buffer overflows, and you manage your memory properly, it doesn't mean you can just get rid of all your security monitoring tools and the infrastructure. You need both, right? And so that's sort of the whole idea is you need it because your AI is going to like it. It's going to start hallucinating. You need it because you don't know if it's actually being fair or if it has its own biases. And guess what? The biases can come from the training, the data that it's given, right? And so unless you trained it and you measured bias and whatnot, you can't really be sure what level of bias exists in your models. And these are not new things. This has been around forever. Like if you're a machine learning guy, you know this. But what makes it even more complicated is these LLMs are such giant black boxes that it's so hard, like how it's going to react to predict that in a real-time scenario, right? And then there's task monitoring, which is like, well, before these machine learning models, they were simple models. You give it like hey, here's something, a feature vector, it's gonna spit out a feature vector or some sort of prediction, and it's okay. There's no toxicity there. Now you introduce this whole level of language, natural language, right? And so it's like, okay, now there's a whole other level of monitoring you need to say, is it doing something harmful, right? Is it saying something harmful, or what? And that's, depends on your application. Maybe you have like something that's, facing customers and you don't want to say something offensive. You're building a chatbot, right? Privacy and security, we talked about jailbreaks. And then, of course, model drift. For those of you not heard of model drift, it's this idea of like, hey, you train your model on something. It's more applicable to the old school ML models where you train your model, you measure it, train test, all of that. And then as the data distribution itself in production starts shifting, your model assumptions are not really accurate anymore. So you might think, oh, I trained my data, it was this accurate. But if the data distribution itself has shifted, then your model is going to get less and less accurate over time. That's just the way it is, right? And the same thing can be true if you're fine-tuning your own LLMs. Well, it so happens that over time, those things can start drifting, right? Because the distribution of the data that you're feeding it can also start drifting. So how do you monitor that, right? So this goes back to the point of like, hey, you might have a question, like you might have heard of all these frameworks like guardrails where you put in all these checks while you're building these Gen AI apps. and you say, hey, check for this, you literally tell the LLM, hey, don't hallucinate. Hey, don't be. This is what people are doing now. I'm not even kidding. Like when they actually write these prompts, they'd say, hey, give me the answer and please don't hallucinate. And, and this is like telling the guy, the smart guy who likes you, it's like, hey, I'm going to ask you this. Please be honest with me. And of course, I don't even know how to respond. Sure. Right? That is the guardrails that people are putting in now. It's like, what? But we told the LLM not to hallucinate, right? I mean, it's so and of course, that's not going to cut it. And plus, it's dynamic environments. You don't know what inputs the LLM is going to get because people can ask whatever kind of question, and there's no way to predict that, right? So. And you don't have continuous observability, which means that you're literally blind about what's happening in your production systems, at least at this level. And then finally, there's no feedback loop, right? So you clearly need something better. So what does that look like? So this is similar to the stack I showed you from before, but with a few changes, if you notice. Now, our application is talking to this green thing, which is just, I'm going to call it the LLM. It's really OpenAI logo, but most people, that's what they're using now. So let's say, okay, you're talking to an LLM, whether it's self-hosted or it's it's a cloud-hosted one, it doesn't matter. And then the other thing which is different, now you got this other black box, I'll talk about that. But the other thing is there's also a little thing here, which I'll get into. So, but the basic idea is still the same, right? You want to be able to push stuff to your observability stuff, but this time you want to start measuring metrics that are relevant to what I was talking about. Hey, is the AI hallucinating? Is it being unfair? Is it like actually, somebody trying to jailbreak into it? Like you want to start answering these kinds of questions and then start measuring metrics that can actually answer these kinds of questions and then start surfacing those in real time so that an operator can then start looking at those, can start setting thresholds against those, can start alerting against those and whatnot, right? So that's sort of what your ideal scenario should be, right? If you truly want to treat it like any other application and you want to have these proper guardrails and the observability in place, that's what needs to happen, right? And so this black box is the one that sort of takes in these traces that are coming in from the application, the GenAI application, and then says, okay, I'm going to try to compute these metrics, right? Now, and then I'm going to start publishing it to your original stack, right? And of course, there needs to be some work done in the app so that those, what is being communicated with the LLM and what are the outputs that it gets needs to be sort of logged as well. Because if I don't know that, then the black box can't really tell what's happening. Is it lying to you? It's not. I need to know what question you asked that smart person and what he answered back. But in order for me to tell, hey, was that a lie or not? I don't know, right? So that's sort of what this step one is. First of all, we have to instrument the application to saying, send me what you spoke with this guy, the green guy. And then, what did you ask him? What was the prompt? And then what did he answer back? And then once I have that trace, then the solution can then be intelligent to try to figure out, okay, I'm going to try to guess whether it was a hallucination or not. And we'll talk about different contexts in which this can happen, how we actually go about doing this. And more importantly, now we introduce a new element here. How accurate is this black box? How do we know if this thing is not lying to us or if it's accurate or not, right? So that's the additional complexity there because it's like a lie detector test. Well, how accurate is the lie detector? Can you fool the lie detector? Of course you can, right? So you better have a really good lie detector. And how do we benchmark those? Right? So hopefully this all makes sense. But the next part of the talk, I want to sort of hand it off to Alex to sort of dive into the black box that I just declared here. Just break it down and say what actually goes on, and then talk about how do we actually measure how good the lie detector is. And then we'll go from there. All right, Alex?
Yep.
I'm gonna hand it off to you. Do you, yeah, I can drive the slides, so let me know.
Okay.
Yeah.
Cool. So actually, I would like to say one quick thing about sort of all these things you said is that I think this measurement story is very difficult because these LLMs have made this big leap in natural language processing. And I think it's important to call it like what that big leap is. It's not, these models don't know anything. This is why sort of like for those people who are very familiar with the models, it's laughable that you're asking, oh, please don't do it. This model it's just a language model, just produces language. So, unless your please don't do the bad thing biases it towards better answers, there's no reason to think it would have an effect. And before, when we used to measure NLP stuff, because we didn't have systems that could process or generate language fluently, we would always break it down into simpler tasks that were therefore easier to measure with classical machine learning techniques. But now we've sort of made that jump, and a lot of the existing NLP data sets out there are just not sufficient for measuring it. So with that, I want to go into like what we're doing with our system to try and measure, and then I'll go into like how you measure the measurement system. So first here, we're looking at like some basic use cases around the idea of how much context and what is being produced by the LLM application. So we consider the first is in like a zero context model. So this is just sort of generic question answering, or sometimes referred to as like closed book question answering, even though it's not always question and answering. So this would be like, maybe you have a chatbot that's intended for the user to come and excuse me, the user to come, but you don't have necessarily like a set of documents or a set of other like resources for it to go off of. Then we have ones where it can augment the context it's answering. So the retrieval augmented generation. So in this case, there is context created at the time of the user question or input. And we want to make sure that the system is staying true to that context. Now, at this point, we start getting into an ambiguity of like what it means for the system to be truthful, to be accurate. Because on one hand, we want it to be, you would ideally want it to just be absolutely accurate. But the truth is, you can really only, fiddle with it to some degree so that's accurate to the text that it's getting. And then you want to make sure that your corpus and your retrieval is pulling the correct documents.
Yeah, Alex, just a second. So just to give you guys an example, the old days of ChatGPT, like you would ask it a question and they would give an answer. It had no way to actually browse the web, if you remember, like the first year or so. That was typically a zero context Q&A, which is you have a fully trained model and it has no access to any other information or knowledge stores. And then all you're doing is interacting with the model. And then whatever the model spits out, and this is why the model will actually tell you, hey, my knowledge cutoff was like October of last year. Anything more recent than that, I have no idea. And so it's just going to make stuff up. Or even if you ask it, even within October, it'll still make stuff up. So it has no access to external knowledge sources. The thing that you start to see nowadays is now if you ask it a question, it'll be like, hey, I'm going to search the web. I'm going to get the top results. I'm going to use that as the context. That's sort of the RAG Q&A context, right? So what it tries to do is it tries to limit its generation of the answers based on the web search results or whatever knowledge context that you're providing. Most enterprise chatbots, they fall within this RAG Q&A context where, because their chatbots will have to search their customers' data, which is not going to be on the web, right? And so they provide that, they feed it to the LLM, and then the LLM sort of uses that as the input to sort of make up an answer, right? But even in this context, there are still hallucinations, right?
Yeah. I think like an example of like of the hallucinations you can get from this is that for example, with that client where and this is more on the summarization side. So summarization is to introduce that. You have much larger inputs. Generally, because it's summarization, it's larger inputs than you have outputs. And it's also similarly a more complex concept of accuracy, because you have this notion of the idea that you want to stay true to the thing you're summarizing is much stronger here, because maybe someone's looking to summarize a document. Maybe they're looking to create summaries of documents containing misinformation. In which case, then you wouldn't want the summary to be absolutely true. You would only want it to be true with respect to or faithful to the context. And this issue of where hallucinations could come out of the context. I'll give two examples from that one client we worked with, One is there were like lists of pre-existing conditions in some of these patient records, and sometimes it would not understand what that list is not necessarily relevant to the current visit. And so it would not be able to correctly associate that list of prior conditions or list of medications with the visit. So it would assume every prior medication, let's say, was prescribed from the current visit. Or similarly, sometimes a patient data would would not contain something. And in the system they were doing summarizations of sections and then having an LLM combine those sections into a single document. Well, that second LLM, that second layer application, did not understand the difference between absence and sort of no information there. So if there was no patient history, it would say the patient has no history of cancer, except this is like a much later visit in it. So they should have a history of cancer. So these are some of the context we have in here. And go to the next slide if you could. So what we want to do with this is we want to ground what we're using to figure out whether it's wrong or not in the claims that are being made. So if you look at what some people are doing out there now with hallucination detection, a lot of it is just asking the LLM, often the same LLM that just produced it, whether it was a hallucination. And of course, that goes into the problem of, is that going to be, how effective could that be? So we go into how effective these different approaches are. But what we want is we want to extract the actual claims, the actual facts being stated, and then to check those against the context. So in this case, we have a triple extractor. So it's going to go through and it's going to create these semantic triples. Well, I think we have that in the next page, but let me get through this first. And then we have a variety of different checkers that we look at. Today, we're just going to look at the LLM checker. So that's something that looks at the claims and determines which ones are entailed or contradicted or neutral to the given context. And then we check those and we calculate a metric based off that. So this gives two benefits over sort of the more simplistic, is it wrong prompts. Is that even if you, in the more simplistic prompts, even if you ask for reasoning, the reasoning is going to be very general. In this case, you can get a reasoning for like each claim. You could say, oh, this claim is wrong because of this. So you could get a lot more feedback from the LLM about its analysis of the individual claims. So when you're reviewing some of these results, you get a lot more data. Next slide. Yeah, so here's an example of like a triple that it extracts. So here we have, sort of clinical speech, 50-year-old man with history of hypertension, atrial fibrillation on Coumadin, and diabetes type 2. And so we extracted, here's some example like triples that we extract. So the patient has diagnosis type 2 diabetes, and Coumadin treats atrial fibrillation. That's something that's implied by this. So a lot of these existing methods for extracting, for even trying to like break it up, they'll do it like a sentence at a time. And even when you do that, you're going to miss out on a lot of like context between the claims. So these triples also have the other benefit where if you have some sort of knowledge source, like another things that we've worked on in the past is knowledge graphs, is that then you can check it actually against a knowledge source that's not text. So maybe you can't check whether Coumadin treats atrial fibrillation by document. I mean, maybe you could, probably, but it might be easier to just say, oh, do I actually have that in my knowledge graph? Do I know that that drug is used to treat this disease? Next slide. Okay, so now we have these claims out. We want to classify them, as I mentioned. So we have 4 groups here. So we have the claims that are in the response and are supported by the reference or the context. You have the ones that's in the response and contradicted by the reference or context. Missing are the claims that are only in the reference. Neutral are the ones that are in the response, and we can't ascertain, we can't determine the truthfulness of them from the context. So your hallucinations are going to be in contradiction and neutral. Contradiction, if it gets classified as that, that's already then labeled it as some form of a hallucination, some form of a incorrect statement made from the input data. Neutrals are much harder to do. This is where you need an extra data source to check against. Our metric does include that, but the measures I'm going to be doing today are just going to be looking at contradictions and entailments. Go to the next slide.
Yeah, and just one thing I wanted to add was, so you remember that person who's lying to you in the lie detector? So the what they're saying is broken down into the sort of semantic triples, right? And these claims. And so we're basically fact checking those statements against what the reference to the LLM was provided. Because we know, okay, here's the set of facts that we know to be true. And this could be company policy documents, it could be customer documents, what have you, patient documents. So those are the sort of our ground truth. That's sort of what we know to be true. So what we do is like, whatever the LLM states, we break it down into the semantic triples, and then by triple or claim by claim, we sort of do this classification process to say which of those claims we can actually validate from the facts, from the knowledge base. Which of these claims actually are contradicting, and those are the hallucinations. And which of these claims we can't really say anything about, those are the neutrals, right? And those are the yellows, right? And then, of course, there's going to be a bunch of claims in the source that the LLM never really talks about, right? So those are the other ones, the missing ones, right? So hopefully everybody's on the same page about this. Anyway, go ahead, Alex.
So this is a metric that we use for it. So we're going to do a weighted harmonic mean of the entailment, the non-contradiction rate, and the reliability if it's available. So in this case, the entailment rate, so that's the proportion of claims that are marked as entailment. Non-contradiction is 1 minus the rate of contradiction, and reliability would be the proportion of those neutrals that are able to be resolved. What this does is it lets us. Real quick, yeah. What this does, it wraps those metrics into a single accuracy measure that you can then weight, because depending on what you're doing, you can tune these weights a lot. You can either say, oh, contradictions are much more important to me, so you just increase the weight, or you can actually weight individual claims you extract by what's the predicate, the sort of the middle part of the triple. What's the predicate or the subject? Oh, I'm only interested in the things about this particular entity. So you can really tune this metric to your use case. Yeah, let's go to the next slide.
So yeah, for healthcare, for example, if you are in a clinical decision setting, then contradictions are actually, much more important to you to try to catch those, then you would weight the contradiction error rate much higher, right, compared to others. So
okay, so now that was just talking about measuring an application by extracting claims and so on. Now we sort of need to move one level more abstract. We're talking about measuring a measurement system. So we're here. I just want to introduce the terminology. So we have the application, and then we have the measurement system. And so we want to figure out a good way to do that with benchmarks. What's interesting is a lot of these benchmarks can be used to either measure an application or a measurement system. So we're going to talk about them just in terms of measuring the measurement system.
So this is basically checking to see how good your lie detector box is.
Yeah.
Right. So this okay, we got a black box that tells you somebody's lying to you, but then how do you know how good that is, right? And so this whole section is about how do we benchmark, the measurement system itself.
Okay, so we're going to be comparing 3 different systems. So here we break up a system in strategies and models. As most of these systems are LLM backed, not necessarily all of them, but for these 3. There's a strategy, so that's basically like your prompt and maybe like other like code or it's your logic that you're doing, and then there's the LLM model that you're using with that strategy, and that's what we would call a system. So we have Pythia, that's the one we defined. we have a simplistic grading one. I wanted this as sort of like a control. Basically, I wanted to come up with a simple one to test against. I made this one in like 15 minutes. So, and then we have the links QA, which is simple in the same way that grading is, but it was the prompt was tuned a lot more by the people who made it on this project. And it checks for this for faithfulness. That's a term it really sticks to. Now, we're also, for the model, we're using GPT-4o Mini for all of these. I did use GPT-4o. I'll sort of get to that analysis at the end. But yeah, I'll get to that at the end. But yeah, we used 4o Mini for all these. So metrics. So we have some options on like how are we actually going to measure the measurement system. So we could use the metrics of each benchmark data set. The pro of that is that these benchmarks sort of like they already come with like a leaderboard. We can compare how this measurement system does to like other systems that were meant to work on this data set. So we're using the labels as intended. The cons, you don't get a general idea of your system. That's a really bad con. And the other one is some of these benchmarks have really bad metrics. So for example, Links QA, they have their own data set. The metric they use is accuracy. Now, theirs is more under what they did is option 2. They combined data from many data sets. They binarized all the labels and then balanced the two classes. And they use accuracy. So by balancing the classes, they take care of the biggest problem of accuracy, that it's sensitive to prevalence. But they introduce another problem. Now that balanced class is very unrealistic. Depending on what your task is, you can have like Vishnu was saying, like, oh, you could have maybe like 27% hallucination, or maybe it's going to be 2%. So you won't really get a clear idea of how it might work on your use case. And also, you cannot extend it to new data sets without doing similar processing in those data sets. You need to obviously binarize the labels, but then you also need to balance it and again, sort of make it artificial. The third option is you binarize it like in option 2, but you use a prevalence immune metric. So the good thing with that is it generalizes, you avoid the prevalence problem, and you don't need to rebalance new data sets. So that's what we did. So let's go to the next slide. So we're using the diagnostic odds ratio for AI. So we're going to call it the DORA metric. So in this case, the diagnosis that we're doing is we're trying to diagnose whether an output is hallucinatory. I give the interpretations of the 4 parts of the of a confusion matrix there. And so in this case, we say that a negative response from the measurement system. So it's saying that it's a hallucination or it's saying it's a bad response. We're going to interpret that as a positive prediction of it being hallucinatory. So go on to the next slide. So this is like the formulae involved in calculating DORA. Another one of the big benefits of using diagnostic odds ratio is that it comes with an easy way to calculate a 95% confidence interval. So we can just like use that pretty simple. So now we have our metric. Let's talk about the first data set. Data set for measuring on summarization tasks. So using these 3 component data sets. So here's the descriptions. They're made from news articles, specifically the CAG, CNN, DM, and SumEval are made from the same data set, but the summaries are generated differently and they're labeled differently. SumEval obviously dominates it, but it's they're all imbalanced data sets still. So here's what we're doing on that one. Okay, so here we see grading does pretty well on SumEval, but overall, it looks like Pythia is doing better. Specifically, worthwhile to call it that Pythia has less variability. Links QA is 0 for these because Links QA only supports the RAG QA use case. Okay, let's go to the next one. So now for our RAG QA data set, we're using part of the Links QA data set. They used 6 source data sets. 3 of them are, and we can go into it more, but they're kind of very artificial data sets. So I sort of removed them. And then we use these 3 and added in another data set called Truthful QA that was actually made for testing the problem of priming with LLMs. So that's like, if you ask a question that's if you ask a leading question of an LLM, how sensitive is it to give the answer you're leading it to? So that's what that data set was made for. So here's how that performed. Again, it looks like Pythia does really well on truthful QA. Lynx seems to do pretty good, but not on the data set it wasn't tuned on. So here I want to talk about the quality versus the cost. So if you just to remind the color scheme, blue is Pythia, green is the grading, and yellow is Lynx. The brown there is Lynx on GPT-4o. In the Lynx paper, GPT-4o performed very similar to their custom model. So what we see here is that in order to get like a reasonable increase in quality, it costs 16 times as much. So cost is another big part because we're talking about big data here, right? You don't want to have to spend a huge amount more to get slightly better measurements. The Pythia model we've tried on a bunch of different ones. It performs similarly across like GPT-4o, 4o Mini, Llama 70 billion. So yeah, that's sort of why we really like our system.
Yeah, in fact, in the recent trends, you see language models. Yeah, they're getting bigger and bigger. Like Llama just introduced like a 400 billion parameter model. The problem with running those is it's going to require a lot of hardware, like firepower, right? And there's actually a trend that's happening within the Gen AI community, where you're starting to see smaller language models that seem to do pretty good for most use cases, right? This is why Microsoft released the 5 set of models, right? And there's Gemma, like from Google, I think is a smaller model. These are like, when I say small, they're typically around like 8 billion or so parameters. And they don't require like massive instances with like the state-of-the-art NVIDIA GPUs and all of this stuff, right? And so this is the trade-off that I think is going to be paramount in the coming years, where it's like, hey, what is good enough for us? And how much are we willing to pay for what we think is good enough, right? And finding this balance and this sort of trade-off between cost and quality is going to be what every data scientist is going to have to figure out. They're going to have to do this analysis for every single task that you're trying to use Gen AI for, including the one that we're using it for, which is just light detection, right? We had to do this for ourselves, but if you're using Gen AI, this is what you should be doing, right? So good.
And the reason that Pythia is doing performing consistently across the models, it's not like alchemy, like, oh, we don't know why. The reason is pretty obvious. The extraction moves some of the task of determining the quality of the overall response out of the LLM and into the algorithm we've defined. If you're leaving the entire task of measurement up to the LLM, that is, of course, going to require a better and better LLM to improve. But if some of that logic is actually in your algorithm outside the LLM, you can improve the quality without having to incur, huge increases in cost.
Right. Which is another way of saying, like, if you don't want to do any data science work, just write up a prompt and feed it to the LLM. It'll do something reasonable. But if you actually want to do the data science work, maybe train your own model for tasks that you think you can actually do better than the LLM out of the box, then you should probably spend time doing this. So you don't have to feed a whole bunch of data to the LLM as part of the prompt, right? And so that's the trade-off that you're going to see, where all the time. So, was there anything else, Alex?
No. Oh, I guess unless you want to talk about the case study.
Yes, you should probably talk about the case study.
So I'll be quick because I know we're running low on time. So this is a case study that I mentioned earlier. So they wanted to summarize these clinical patient reports. And one of the interesting things, like we found, first of all, in their summarization, we found very low instances of hallucination. Again, sort of like building on the point we just said, that's because they had this multi-tiered system where they did summarization of a small piece of text, and then they did a combination of these different pieces into the summary. Really what we found is one of the main sources of problems with some of their data was actually their OCR, was scrambling some of the text lines. But other than that, we were able to like show that our tool was accurate with the human judgment, because we had our own human judge, and they also had their own human judges to review the results. And the ranking of sort of quality of like different LLMs, because they were testing us against different LLMs, we produced almost the same ranking as their humans.
Yeah. And the important thing to note is like they didn't really have any automated way to measure any of the things that we produced in this report. They were literally using human judges, like to go through result by result, and sort of annotate them. And that was sort of their golden set they had. But once again, just having a golden set doesn't mean your system is going to behave the same exact way in production against production data, right? And so what we gave them is like not only a way to sort of automate the testing on any kind of data set, but actually do this continuously in production against real data, right? To be able to tell with a certain level of confidence their system is behaving right? And so that was the huge plus for them. So, then I think there's a demo where we talk about how to instrument the whole thing. So remember that whole stack I showed, like this basically shows how you can actually do this using our tools. There's an
We
open
have
source
our
version.
Pythia Docker stack with all the components, including Prometheus, Jaeger, Telemetry Collector, and also Grafana. And all this stack can be run locally by a simple Docker compose command that will include all the configuration for all the services. And if we want to start with taking care of the traces, we need to initialize Pythia traces by using the Telemetry Collector endpoint, and by passing in, if we want to use ChatGPT, an OpenAI key. If not, we can directly point it to an LLM and use that LLM for the references. In the next step, we will use some simple example of calling like OpenAI with context, the LLM with the context and a question, and then the response that will be obtained will be automatically saved into traces in Jaeger. And we will see right now the traces in Jaeger. That would be like the completion and also the prompt that was sent, like all the references. And then based on that information, Pythia is picking up automatically whenever traces arrives into Jaeger, and will create metrics and accuracy metrics for entailment, contradictions, and neutrals, and also will detect claims that will be stored and will be exposed to the end user. And that information will be then also exposed in Prometheus. And now, in order to have a better visualization of the metrics and all the statistics, we are using Grafana, and Grafana is pointed automatically to Prometheus. And by simply creating like a connection and selecting what metrics we are interested in, we can expose them and have like a clear understanding of what happens to our responses from the LLM and how accurate and responsive are the results. Here we have our Pythia Docker stack with all the.
So there we go. As you can see, so we went from that picture I was talking about, how you instrument your application, push out those traces, and how the black box there would sort of process that and write back those metrics that you can then visualize. So this is sort of how all of that really comes together, right? Just a final note would be like, yeah, I think AI is going to keep getting better. The models are going to get bigger and more complex, but that only says that like we gotta develop these mechanisms to start observing this, see what they're actually doing, right? The person is just getting smarter and they can still keep lying. It doesn't mean they'll stop lying. This just means they're going to get more and more sophisticated in how they actually lie to us, right? And mission critical industries. If you're in healthcare, your finance, your legal, like even a single hallucination could mean millions of dollars for you, right? That's why you need continuous monitoring. And I think eventually we can go from this prevention to prediction. Like, what if because now we're starting to collect these metrics of when things hallucinate, we can start saying, oh, these are the kinds of inputs or these are the kinds of scenarios where my LLM is actually hallucinating more. And maybe not just putting rails, but also start predicting when it's going to happen. So, and to say that, hey, if you're not already doing this, if you're considering doing any kind of Gen AI that's in the mission critical industry, you should actually be looking at observability solutions like these. With that note, we have put out like an open source version that feel free to try. Use that QR code, goes to the GitHub. Join our subreddit to continue the conversation on this reliable AI. We're really obviously passionate about that. We also have a hosted version, SaaS version that you can give it a try, and just to get started on that if you don't have your own observability stack already set up. With that, I'll open up the floor for questions.
Is Pythia basically another LLM that checks common LLM?
It's more than an LLM. It's a complete system, right, that actually has its own strategy. So there's two components. There's the strategy, which we take these context in the LLM responses, break it up into claims, right, and then checks against those. So it's a whole system that sort of does that, right? So
yeah, because I'm curious about under technically speaking, people can build another agent just to sort of do a checking and
yes, and that's basically what Pythia is, right? It's the agent that sort of checks what your LLM is actually doing, right? So
just to clarify, when you show some benchmark results, so was the model under test with ChatGPT 4o mini, or was it?
So so it's interesting because we're not testing the LLMs, and see, we did do that, by the way. But the point was not to test if the models were doing good. Oops. It was also to test which strategy would actually do better, right? And so we tested both, like, hey, different models, how do they do? But there's also a combination of strategy, which is like, oh, how are you trying to find hallucinations? Are you just simply asking the LLM, hey, is there a hallucination? Or are you doing something more sophisticated? That's what we call strategy, right? Pythia strategy is what we just talked about. We break it up into these semantic triples, and then we sort of do this comparison and all that. That's our strategy. Now, Lynx is another solution that they have a different strategy. The grading one was what Alex talked about. That's a different strategy. So you can have different strategies of how you actually go about using an LLM. And so in some ways, we wanted to measure how good these strategies are, keeping the LLM the same. Now, of course, we also varied the LLM to see if the LLM would make a difference. And this whole thing, Alex is writing up this as a paper. We're going to publish that. So you'll see that. But these metrics, all the LLMs are the same. So we're not changing the LLM, we're just changing the strategy, because you don't want to change the LLM and the strategy, because then those results are not comparable, right?
My major concern why I asked it is, so with the newer models that are coming out, right?
Yeah.
So with them, what I have seen, I use LLMs almost daily. So what I've seen is, you're talking about hallucination. So that part is kind of reducing a lot.
Yeah.
So when you check Llama 1, 2, and 3.
Yeah.
So
when you say newer models, which model are you using right now in work?
Llama 3.
Yeah.
Yeah.
So Llama 3 is going to have results that are going to be worse than this, like on these benchmarks, guaranteed. We already ran it on Llama 3. If GPT 4o mini or 4o is having these results, I can guarantee Llama 3 will be much worse.
Okay.
Right? So if we ran these benchmarks on Llama 3, you'll see comparable results, if not worse. Right? And we've already done this. Like, right, Alex? We've done Llama 3 testing as well.
So yeah, what we found, because we did sort of like the varying strategy and varying model against each other to see what the difference was, and for the most part, varying strategy was way more influential than varying model. The only strategy where sometimes Llama 3 would be a better performer is on like one or two data sets with links, and that's because again, sort of like in the Lynx project, as they were developing this prompt and this data set and their model's actually a fine-tuned version of Llama.
Yeah, it's just overfitting, right? Some of these models, you got to remember, they actually memorize stuff, right? They're so powerful they can actually remember things. And so when you feed the same data set to then test it against that, you're going to see good results, because it's literally just remembered what it was trained on.
And even like if you're tuning your prompt to a model, it's you should not underestimate your ability to fit your prompt to a particular data set. So even prompt tuning can cause overfitting.
Yeah. Yeah, we'd love to talk to you guys, like, about it. Okay. It's very easy. By the way, we're going to publish these benchmarks as like reusable like notebooks and stuff. We'll let you know. We'll work with the organizers, but so you can run it on yourself, right? You can just say, point that to your model, your deployment, and just see how good your system is for yourself, right? It should be pretty easy once we write this paper up and like we'll publish it. should be good. We'll link it to the GitHub as well, so. That's a good
And
question.
I want to say like one quick thing is like towards like this being like a new field, like just as we're moving towards that plateau talked about in the earlier Gartner visual, this is going to be like a very hot field, this measurement, because we're going to need to develop new data sets, new metrics, new measurement techniques. So, you know, there's so much stuff that as like someone like a data scientist like me who's like really obsessed with metrics, there's so much stuff I know that needs to be done, and it's just basically on the roadmap of stuff that will be done.
Yeah.
So yeah.
These models are getting sophisticated. Like last week, I can't even keep track of time anymore, but I think it was last week when they announced the O1 series of models, right? With the whole chain of thought. So if you're following that, basically now OpenAI has words where like they do a chain of thought to try to sort of just think about their answer, like reason it out in multiple steps before it tries to answer the thing. And so the idea is by doing that, the chance of hallucination will go down. And the truth is, it will go down. Of course, the trade-off there is it's not going to answer right away. It's going to take 9, 10, 11, 12, whatever seconds, right? It's going to take a while before it answers. But once again, that will not eliminate hallucinations. It will reduce it. So it all boils down to what is the hallucination rate that you can live with for your use case? And have you measured it? Have you put mechanisms in place to even measure that in production, right? And if you put that in and you're saying, hey, we can live at this rate, we're fine. That's fine. That's a business decision that your company needs to make, right? And that's sort of the bigger point. If you take away nothing else, is like, you should be at least measuring and monitoring what's happening in your production systems with these Gen AI systems and not be blind to it. And don't trust what the benchmarks are telling you that these companies are putting out. That's on their data set. That doesn't mean you're going to get similar results on your data set and your customer data. It does not at all mean that. You have to verify that for yourself, right? Yes.
No question. So when you extract the claims, is the context going to be lost? Because lots of claim actually is subject to some certain condition, right?
Yeah. So this is a good problem. We've seen this where like, do you want to be too granular when you break up the claims? And this is where the claim extractor has to be careful, where you don't want it to be so granular where the context is getting lost. At the same time, we've also seen the other problem where it'll just group a whole paragraph as a claim, which is also not very helpful, right? So there's experimentation that we've done with like what level of granularity you want in these claims so that you get the right level of context still maintained in these claims. So it's good enough for us to actually use it. Alex, do you want to talk about the claim extraction itself and how we?
Yeah, I would say, sorry, as far as like the context of the claim extraction, there's sort of like two aspects. There's more of like a vaguer notion of context, of sort of like a semantic context to it. And I would say that the claim extraction sort of intentionally is trying to reduce that so that we can say like, okay, this piece of text is saying this. But then there's another part of a context we can't lose, which is like, what happens if it's negated? What happens if it's a quote? What, you know, those sorts of things. Those are, as Vishnu was saying, those are issues with the extraction. We need to tune it over time and with different data sets. So for the most part, we've not run into many problems with like the use cases we've had.
In fact, Alex, I remember like early on when we were doing this, our extractor used to sort of be very granular, right? It's not, and in fact, we saw that was actually giving us problems. Like we have two sort of bulky claims. It would literally just take a whole paragraph and then treat it as like, this is the patient, like an example would be like patient had a diagnosis of hypertension, blah, 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 blah. And that was the whole predicate. Right. And that was largely useless, right?
And the big problem that would cause is that because a lot of times that big blob of text, well, not a lot of times, like some portion of the time, it would be paraphrased, either paraphrased in the summary generation from the reference or paraphrased in creating that triple. And then when you check that against the reference, the checker would fail to recognize it being entailed because of the paraphrasing. And so when you the more text you're generating, the more likely you are to paraphrase. So yeah, definitely encouraging smaller stuff is better. The other thing we found is that we actually get equivalent results when we check all the claims at once. And what that does is so the initial method we tried with, we were checking the claims individually. Obviously that's too expensive, so we tried, okay, let's just check them all at once. It does. Once we started using GPT-4o and then 4o mini, checking all the claims at once worked pretty well. And not only do you save cost, but that actually restores a lot of the context. Yeah.
Yeah. By the way, one thing we didn't talk about is how do we use knowledge graphs in Pythia, and it goes back to claim extraction, to your point. Now, typically, the way to avoid that is like you actually have an ontology that you're sort of driving towards. In the examples that we showed you, we didn't really convert this to an actual ontology of claims, right? It was just like, hey, it was just sentence-based things, which is whatever. This is what GraphRag and all these other techniques do. Ideally, you want to sort of map those to a proper ontology. Then you won't have the problem of like, hey, is it too fine, is it too granular? The ontology sort of takes care of that. Now, if you had a knowledge base and you had like all of the ontology in the graph built out, then it sort of matches to what you know about this, what the ground truth and the set of facts. And it'll be easy to then just compare like, hey, this semantic triple, does it exist in the knowledge graph or not? Right? That is another way you can sort of introduce this sort of fact checking, if you will, which we don't even do right now. We just look at what was provided in the LLM and then we try to answer. But it is possible to also reference a knowledge base if you already have built out one. So, yeah, question. Yeah.
So I think you vaguely mentioned the idea of using like Pythia to possibly predict when the model is going to hallucinate. Have you seen any indications of like strong or what could cause hallucinations currently?
So is this like what in the testing we've done, have we seen like what can cause hallucinations?
Yeah. Or in our case studies or any of the examples that, yeah, we've seen, yeah.
So I would say like in the case study we talked about at the end there, one of the sources of hallucinations was OCR. So this was so if you have columnar text in the PDF and then you turn that, sometimes the lines will get shuffled together, and that of course can cause hallucination because the LLM will force some sense onto these scrambled lines. The other source of hallucination is so it's more sort of like a linguistic issue where if you have something that's phrased awkwardly, so what does it mean awkwardly, from a linguistic point of view? It means it's phrased in a way that's uncommon. It may not necessarily be like grammatically incorrect or something, but it's just phrased in a way that's very uncommon. LLMs, by their nature, will try and produce the more predicted phrasing. So if you are doing something like something, let's say I'll give an example of like poetic speech, like the best LLM it was not, right? So that's sort of like poetically phrasing it. Those sort of like weird phrasings can cause it to misinterpret like the negation. So those would be like two of the situations where we noticed the hallucinations. Yeah, those are the two that come to mind.
Yeah. So
I guess no. The other one is what Truthful QA was actually made for, like the priming. So the example I give for this, if let's say you have a person who doesn't like vaccines, asks a question of your medical chatbot. The concern is if he comes along and says, "What terrible vaccine injuries are caused by this flu vaccine?" That's called a leading question, or another term in linguistics for it's called priming. Prior to GPT, so 3.5 and prior, they were very susceptible to it. As a matter of fact, 3.5 was more susceptible than 3 at that. GPT-4 seems to be pretty resistant to it because I sort of like just measured the GPT-4 directly on that, and it seemed to be pretty resistant judging by that data set. So, but that's sort of a person asking a leading question that's another source for hallucinations.
Yeah, at the end of the day, remember, like, there's the language model, and then all these systems also have like a reinforcement learning model, right? That actually decides which of these different generations it has to pick, right? And that reinforcement learning model is literally, it's trained to please the user. It's going to tell you what you want to hear, right? And so if you phrase the question a certain way, you sort of display those overt biases in your question and this priming, it'll try to sort of please you as a user, even if the context and the facts don't really support it, right? This is what it was trained to do, right? So
And the threat becomes doubled when you're using RAG, right? Because when you have those sort of like really biased questions, you're not just gonna. There's not only a risk of the LLM being biased, but there's a good chance you will be more likely to pull documents that agree with you. That's sort of like that sort of problem of like, oh, I did my Google research and everything confirmed your biases. So when you do RAG Q&A, these biased questions are actually a bigger threat.
Yeah. It's the Fox News effect, right?
Yeah.
Oh, great question, Tim. I think we're way over time, but yeah.
I think with that, yeah, we want to thank Vishnu and Alex for the talk.
Take a picture of the QR code in case, you guys want to try it out or, join stuff, this is recording and all that, but thanks a lot for the great questions, the great discussions, yeah, and the opportunity, yeah.
Yeah,
Thank you.
so yeah, feel free to stick around like for another 10-15 minutes. There's still pizza. And if you want to chat or get into it more, you can.
Yeah, Alex, you can drop off if you
Okay. Feel
like you need to get dinner. There's no pizza.
Yeah.
Or you
I have a hamburger waiting for me. I'm okay.
Okay, thanks, Alex. Yeah. Okay. Yeah. Yeah, okay, like old school business cards.
I love it.
Yeah, because I'm really old.
No, yeah.
But yeah, love to chat up, like, hit me up on email or whatever, like, what is your?
We're part of monks.
Just anything.
Yeah, we all opened an office in January, so
Okay.
that's pretty hard.
Yeah, I'm pretty actually, I think there's something like, guardrails approach is what like most people, when they think about reliability, they think about, okay, let's just put more stuff in our application to make it smarter. Yeah, I think that's good. I think that's better than doing nothing. But you're not gonna catch all the use cases and you can still publish your data something like you're continuously to see what's happening. Yeah. And it's not even, you gotta know, right?